Another question was to find the distance between vectors 2, 3, 1 and the vector -3, 0, and 2. To do the distance, it's a square root, number minus the number, so -3 minus the 2 squared plus 0 minus the 3 squared plus 2 minus the 1 squared. -5 squared is 25, 3 squared is 9, 1 squared is 1, so that's the square root of 36, so the distance is actually 6. Now, another question was, say you have this vector 3, 2, -1, and you have this vector, and the question, do they form, or are they, and this means are they perpendicular to each other? For two vectors to be perpendicular, the dot product must be 0. So you do the u times v. 3 times 1, 3. 2 times -1 is -2. -1 times 1 -1. So the dot product is 0. Yes, they're perpendicular to each other. Another question was, let theta be the angle between u and v, where u is the vector 1, 2, 3, 4, and v is the vector 5, 7, 8, 9. Find cosine of theta. The rule for cosine theta is u dot v magnitude u magnitude v. So cosine theta, u times v, again, 1 times 5, 2 times 7, 3 times 8, 4 times 9. Magnitude of u would be 1 squared, 2 squared, 3 squared, 4 squared, times magnitude of v would be 5 squared, 7 squared, 8 squared, and 9 squared. Eventually, when you do this, it's 79 over square root of 80 times square root of 219, 9746. And if you need to find theta, theta would be cosine inverse of 9746. Now, there's a question. When you do the cosine inverse in the calculator, if angle is less than 90 degrees or pi over 2, we call this acute angle. If more, it's obtuse angle. So in this case, this would be an acute angle. Anything less than 90 degrees is acute. Anything more would be obtuse. Okay, another question was, let's say you have this point 1, 1, minus 1, and this point, and this point. Now, these 3 points represent a triangle. Prove that ABC, this triangle ABC, is a right angle triangle. Okay, so we're going to do 3 vectors here. U would be AB. A to B would be basically this minus this, this minus this, and this minus this. We do V, BC, and that would be C minus B, 2 minus 3, 2 minus 2, and minus 4 minus minus 2. And you do W, which is AC, C minus A. This minus this is 1, 1, and negative 3. So if this is point A, point B, point C, you have vector U, vector V, vector W. To prove that this is a right angle, when you do the dot product between UV, UW, VW, one of them must be 0. So we're going to do the dot product between UV, UW, VW, hoping that one of them is 0. If one of them is 0, then this is a right angle triangle. We start with UV. This time this would be minus 2 plus 0 plus 2, negative 18. UW, this and this would be negative 4 plus 1 plus 3, that's a 0. And VW would be 5, 0 plus 6, 11. So yeah, one of them is 0, then yes, it's a right angle. And which one? It was UW, so that means that this angle CAB is right angle. Good? There was a question of projection. Find the projection of V onto U and sketch. Now, U is 3 minus 1. V is 5 minus 1. Now to do projection of V onto U, the rule says it's U dot V magnitude U times the U vector. Basically what this means is do the dot product between them. 3 times 5, 15. This time this is 1. To do the magnitude of U, but since it's the magnitude times the magnitude, so you don't need the square root. So you basically go 3 squared and the 1 squared, or the negative 1 squared. No square root because you multiply it by each other. And whatever that is, times the vector. So that would be 16 over 10, 1.6, times this. So the projection would be 4.8, negative 1.6. This here is the projection. Now to sketch this, since I'm out of space, I'll use the space here. To actually sketch this, let's say you have 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. Okay, so the first vector, U, is 3, negative 1. This is the point 3, negative 1. You connect them, that's vector U. You also need 5, negative 1. 5 with negative 1, that would be this vector here. And the new vector you just did was 4.8 with negative 1.6. So 4.8 would be here somewhere, with negative 1.6 would be here. Now you gotta make sure that this new vector, since you're doing projection VU, the new vector, the result, will be at the same level of U because it's a projection on U. So you gotta make sure that the result of projection will be at the same level of U because it's projection onto U. Okay? Now, they want you to, in question here, you have 3 points, 1 and minus 1, 2 and 2, 4 and 0. They belong to a triangle. So if you want to do it quickly, let's say 1, 2, 3, 4, and the minus, and 1, 2, 3, 4, and minus, one and minus 1, it would be this point here. 2 and 2 would be this point here. And 4, 0 would be this point here. This is a triangle. They want you to find the area of this triangle. Now there is a rule for the area of a triangle, assuming that each one of them, like this, is a vector, 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 so like you have 3 vectors, you take 2 vectors, let's say we call this vector u and this vector v. So again, this is point A, this is C, this is B. So you take 2 vectors u and v. Let's find them first. Vector u would be AB, and that's 2 minus 1 and 2 minus 3, minus 1 would be 3. That's the u. Let's take the v, and that would be AC, C minus A, so that would be 3 and 1. Now after you do this, again, we're trying to find the area of triangle here. After you do this, you find the magnitude of u and the magnitude of v. The magnitude of u would be 1 squared plus 3 squared, and the magnitude of v would be 3 squared plus 1 squared. And that would be root 10, root 10. Now, area, the rule for area is half magnitude u, magnitude v, sine theta. So we need to find sine theta. But we can't find sine theta, so in order for us to do the sine theta, we need to do cosine theta first. And you remember the rule for cosine theta, it would be u times v over magnitude u, magnitude v. We did this earlier in one of the questions. So u times v would be 3 plus 3, and the magnitude times the magnitude, that would be root 10 times root 10. So that would be 6 over 10. Okay, which is 2 over 5. Now that's for cosine theta. We need sine theta, but you know sine theta is the square root of 1 minus cosine squared. So it would be 1 minus this number squared. Again, I'm going to use the space I have here. So that would be 1 minus 4 out of 25. This is the square root of 16 over 25. That would be 4 out of 5. So that's actually sine theta. Now to put everything together, area would be half magnitude u, magnitude v, sine theta. Magnitude u, root 10, magnitude v, root 10, and the sine is 4 out of 5. You'll see that root 10 times root 10 is root 10, and half is 5, and the 5 here cancels with the other 5. The answer is 4. Okay, now the last question is regarding imaginary numbers. So the question was, write the following number in the form a plus bi. And it was 7 minus I, 6 plus 7i over 1 plus I. So we want to write it as one imaginary number. We do the top first. 7 times 6 is 42. 7 times 7i is 49i. Negative I times 6, negative 6i. And negative I times 7i is negative 7i squared over 1 plus I. Now, I squared is negative 1. Negative 1 times negative 7 is 7. 7 and 42 is 49. And this minus this would be 43i over 1 plus I. To get rid of the 1 plus I in the bottom, we multiply this by the conjugate. 1 minus I, 1 minus I. We do the top first. 49 times 1, 49. 49 times I, negative 49i. 43i times 1, 43i. 43i times negative I is negative 43i squared. And when you multiply the bottom, 1 and 1, and I and negative I would be like this. Again, I squared is negative 1. So negative 1 and negative 43 would be positive 43. And this would be 92. Negative 49i plus 43 would be 6i. Negative I squared is negative 1, and negative would be positive 1, and 1 is 2. This over this is 46, and this over this is 3i. Again, this is basic stuff. It took me actually a long time to do it because I couldn't do it on the computer. System requirement, I couldn't open the website. I had to do it on the phone. And using my iPhone to do the assignment wasn't very practical, but I managed to do it. It took a long time, but I managed to do it. But as you see, it's mainly basic stuff, nothing really big deal. So please review this, and hopefully you're not going to have any problem with it. Good luck.